Y'all thought I was gone, huh? Well, I'm back from a midlife crisis, but that doesn't matter because today I'm going to show you how I program procedural trees. Cause I know y'all love the procedural grass program, but procedural trees, that's going to be something else here. Some real beauty, probably you've never seen. So, where do I begin? I first started this small project cause I needed some new trees for the survival game. So I decided to just model it in Blender, but this was the best I could do. So after that, I was like, fuck it, let's just make some procedural trees instead. So, like a big IQ programmer that I am, I just reused my grass mesh generator that was made in Unity, rewrote it to have more than just 3 sides, and control the thickness so it can look more like a stem. Plus, in the grass program, segments were just flat, so I tinkered that so each segment faces direction based off the control node's positioning, and this little small modification just simply improves the look for the tree stem to give a better visually appealing low poly mesh. And next up was generating branches, and they would basically just be the same as creating the stem, just at a different start point and generating at a different direction, right? That's what I thought I would do, but I was having trouble rendering the branches' faces here, and I tried my own several solutions here trying to take account of the direction of the nodes that were positioned, but I couldn't figure out how I would calculate the branch mesh triangles, so I had no choice but...
This goes against everything I stand for, but desperate times call for desperate measures.
I found this forum from Unity and my first impressions were just a little overwhelming, but it's only because I didn't expect there to be that many lines. Besides, the guy had some comments, so that was nice. The problem this person was dealing with was rotating the vertices based off the curve's orientation, like me. But cause this was in C# using Unity functions, and I only wrote like probably less than half the code here, and the mesh tangents were required, so I tried looking into how to calculate tangents and thought this just wasn't worth it for me, man. Instead, I moved on to a different forum that was also Unity and had a similar problem, but was a more simpler solution that didn't require to calculate the mesh's tangents. So I quickly read the forum's following steps, coded it, ran the program, but
oopsie whoopsie, ooh, we made a fucky wucky, a little fucko boingo.
And that happened, exactly just like that. Nah, for real, I just fucked up my code here, just needed these couple of lines here. And after that strange error that somehow happened, my mesh path generator was updated and still had the same stem here like before, but if I add some branches here by defining nodes coming out of the stem, I can get something like this now. A pine tree, which was the goal from the beginning to create taiga trees. It isn't half bad.
It's the biggest piece of dog shit.
Or maybe I need some more tweaking. But do you know what's the best place to get inspiration from? It's nature. And if you're smart, you may be thinking, oh, he'll be generating trees with fractals and L systems.
No.
I'm not gonna lie, I just wanna use a space colonization algorithm instead. And it's not actually colonizing space. Not that you really thought that's what it was, right? But here's a Medium article, Modeling Organic Branching Structures with the Space Colonization Algorithm in JavaScript by Jason Webb. Yeah, it's a long ass title. I know. As I read some of it, it mostly involved vectors. Oh wait, you never heard of what vectors are? You don't know what vectors are? Well,
it's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector!
Well, now you know. And when I saw this step-by-step diagram, that's when I knew how. And I'll explain. Well, it first begins by setting initial nodes and segments. After that, set a number of random position attractors. The role of these attractors are there just to affect how the tree will look like. Third, figure what attractors are affecting which nodes. So look for attractors that are close enough to nodes at a threshold distance. Fourth step, for every attractor to node relationship, calculate the direction vector for each node. Then, for each node's directional vector, average them up and normalize them. And after that, with the final direction vector for each node, create a new node and segment. Lucky 7th step, remove attractors that are in the kill zone distance from any node that's within a threshold. And repeat the process from the 2nd step, and the process ends either when there are no more attractors, or in my case I just hard coded a maximum iteration. And last but not least, smash that like button for more animations like this, made by me with Python and GLSL. So after programming a version in Python, I moved this code to Godot and tweaked it to make this to a 3D version. And I didn't know how to render lines in Godot, so I just didn't bother. So instead, just spawns spheres to represent a tree. So with this 3D version running in Godot, I need to divide the tree branches up because my path mesh generator algorithm can only generate single shared node lines. So meaning lines that are sharing the same nodes are no-no. So I needed to create a branch mesh class to store branch data and iterate backwards the tree structure branch segment that I've already recorded. And by checking if there is a branch segment sharing another branch's node, that's how we know that'll be part of the chain in a branch mesh object. But if there isn't another branch that shares another node, then a new branch mesh object is added to the list. And this is done till every branch segment is iterated, resulting with this tree that I color coded with their group of branch. So with the space colonization algorithm and the tree branches already segmented, I can test it with the path mesh generator, and I was happy to see that it worked in the first try, and stored the branch's lifetime from the space colonization algorithm to shape the width of the branch that'll make the tree look more like a tree. But why stop there? Even though it was already cool to have this procedurally generated tree, it already felt a bit lackluster for me. So I had an idea to give it some wind force, but it was going to be a bit tough since I need to figure out how to move the nodes and update the branches meshes. So I came up with this idea to just reprogram the entire generator for nodes to be a parent-child relationship, so transform nodes can affect other nodes. And programming this wasn't actually complicated, it just involved simple position and rotation transformation seen right here. And I had to reprogram the segmentation algorithm to a short recursive function cause why waste time, say lot word when fewer do trick. And naively created a update mesh function, and then finally randomly rotated branches with Perlin noise, resulting with this. And yeah, I think this time it looks a lot cooler now. But now that was done, I had to deal with the fucking leaves. And let's just say, I don't know if it was a success, but at least I found a way that decently looks fine for now. But with my first attempt, I found these leaves somewhere on the internet, randomly placed them around branches, and randomly rotated them. But instead, I ended up with this jumbled mess. And what I was trying to do here was create a bunch of billboards of leaf textures around the branches. And that's the thing here, because they weren't fucking billboards. I actually fucking forgot to toggle the billboard option in the material tabs. But it still didn't look right to me. So I thought maybe to make the trees look more like trees was making my own leaf pine texture in Krita, since I couldn't find anything else on the internet. And now you're probably thinking, how the hell does he think he's going to make things look any better from now?
You must believe.
Never mind, it looked absolutely trash. So with the last failed attempts, I just googled a pine tree branch and in Krita removed the white background and set it up on Godot. But it won't be a billboard this time, and created the leaves with the new tree mesh path generator, as the last attempts were actually created with the old mesh tree generator. And programmed a bit of a wind to the leaves to add some realness to it. But if anyone has any ideas for better ways to create leaves, I would love to read some comments below, because I don't know what's a better optimal way to do this. So now with all that being done now, here's a few trees to take a look at. Simply look at them and view it. Judge it for yourself on the comments below. Or just smash the like button please. But to wrap things up neat like a bow, Everything I did here was just to make procedural trees, and it was a lot of fun for me to program, so I hope y'all found that pretty cool and enjoyed it. But now that you've reached the end of the video, it's time to explain my long absence. It's a bit of a long story, but short story is I dropped out of school, been mostly working, dealing a bit with a midlife crisis, been feeling a bit lost. I felt worthless. I felt ugly. I felt gay. You know what I mean? Life is like a bunch of problems attacking you in every way. But I feel fine for now. So this time just gently tap the subscribe button for me. Just gently tap it. Be nice to it. For more content here. So yeah. But speaking of which, thank y'all for helping me reach 300 subscribers, bringing me another closer step to reach 1,000 subscribers, and hopefully for more to come in the future.